Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello guys, I'm Dhiraj and I welcome you all to Testbook.com, and I'm here to provide you the best I have. So guys, once again, I came back with another session on GATE previous year question for 2021, right? So guys, today in the last class, in the last session, we have finished what, my dear, what we have finished? We have finished RAC, right? We have finished refrigeration and air conditioning, and before that, we have also finished thermodynamics. So right now, we are going to deal with the previous year question of GATE mechanical, and that subject will be nothing but power plant engineering, right? So bacha buddy, we are going to start the session, but before starting the session, let me check that how many people have already joined. So I can see that few people have already joined. So guys, we can start the session within 1-2 minutes, okay? And after that, we'll solve a lot of questions, and you will have an understanding of the previous questions pattern, their concept, and you will get the things that from where which topic is going to be a most important topic, power plant engineering. That means it is nothing but 4 in 1 session. 4 in 1 session. You will get benefited, that is practice. You will come to know that is the paper analysis will be done, right? And you will come to know the topics which are very important, right? And this session is going to be a very, very useful for the guys, those who are in 3rd year and final year, right? It is also useful for the guys, those who are preparing for the GATE mechanical, but it is going to be very useful for 3rd and final year students, those who appear in the BTech, okay? I hope everybody got it. Yes, bacha party. So, okay. We are going to start the session within 1-2 minutes. So guys, be with me for at least 1 hour, and after that, we'll start the session, okay? So within 1 minute, I'm going to start, okay? Right now it's 2:59 and our timing is from 3. So at sharp 3, we are going to start the session, okay? And my dear, those who are joined first time, I want to let you know some offers and kind of opportunities for you guys with the testbook.com. So regarding that, my dear, we have yearly textbook pass. You are getting textbook pass just for rupees 299. In addition to that, you are getting 3-month plus Ghana subscription, and that can help you to listen a motivational music, right? And my dear, in this pass, we are getting 100 plus courses, 12,000 plus test, right? And it includes all the category of examination, whether it may be related to teaching, defense, technical, non-technical, UPSC, state engineering, everything has been included in a single pass, okay? And my dear, there is an offer on Mission Gate that is right now it's 45-50 days are remaining for that GATE mechanical. So my dear, you can prepare well, and you are getting it just for rupees 3,999 rupees. That is almost 4,000 rupees. So guys, get benefited of this opportunity, okay? And my dear, if you are interested in SSC JE Mechanical live coaching, then you have to fill the application form, and the link of that application form has been provided in the chat box, as well as, my dear, it is available in the description of this video. So you can fill the application form, and whatever the queries you have, that will get sorted out by the textbook counselor once you fill the form, okay? So guys, these are the various offers and opportunities and the programs run by the testbook.com for you guys. So get benefited of this opportunity, okay? So bacha party, right now it's 3. So we are going to start the session. So my dear, here is the first question of today's session, okay? See again. Given below an extract from steam table. This data has been taken from the steam table, okay? They ask specific enthalpy of water in kilojoule per kg at 150 bar and 45 degree centigrade. My dear, see 203. तो आप देखोगे 203 तो पूरे डेटा में नहीं दिख रहा. But I want to tell you one thing before that. Suppose to, my dear, I have pressure, and corresponding to this pressure, supposed to be I have temperature. That is nothing but what, my dear? Saturation temperature. And supposed to be I have temperature which is less than from T side. Then I can say this particular liquid is nothing but what, my dear? Compressed liquid. If you remember that, I have already told and very well explained in the class of pure substance, if you remember, my dear, right? And my dear, I want to tell you the properties of the compressed liquid is not going to be vary with the pressure, right? It is more dominated. It is going to be vary independently. And my dear, it is more vary with the temperature. Temperature के साथ में काफी ज्यादा vary करती है. When your temperature varies, my dear, definitely there is a variation in the properties, right? So regarding that, they are asking at 45 degrees centigrade. That means we are not going to see the property at 150 bar, because I already explained that compressed liquid property is not going to be vary more dominantly with the pressure. It is going to vary with the temperature. So my dear, at 45 degrees centigrade, I can see that the saturated enthalpy, right? Enthalpy we have to find out. So it is nothing but what, my dear? And they said enthalpy of water, that is what, my dear? Enthalpy of liquid. So it is 188.45. So definitely the answer will be number 4. I hope it's clear to you. I hope it's clear to all of you, right, bacha? I hope it's clear to you. Okay. So if it is clear, my dear, then I'll go for the next one. Okay. So here I go. Here I go for the next. Which one of the which combination of the following statement is correct? इसमें से कौन सा statement correct है, right? So always the incorporation of reheater in steam power plant. When you incorporate reheater inside the steam power plant, then my dear, which are this statement will be correct? Always increase the thermal efficiency. No, thermal efficiency may increase, may decrease. So definitely it should not be P. So my dear, now I'll check the option. So this is not going to my answer, right? Right? Yes. See, this is the elimination technique. Automatically option number 2 will be correct, because I know that P is not going to be correct. Yes, thermal efficiency increases, no doubt, no doubt. But sometimes it also decreases. We cannot say that it is always increase. It may increase, may decrease. And I want to tell you that reheater, the main purpose of reheater to improve the dryness fraction, that is X, and which is nothing but mass of water vapor to the mass of vapor plus mass of liquid, that is in mixture, right? So my dear, we can say P is not going to be correct. So definitely the option will be number 2. I hope you got it, everybody. Very good. Okay. So now, my dear, I'll go for the next. See, I hope this diagram is visible to you. Bacha body diagram is visible, now. Very good. It's visible. So my dear, see, thermal power plant operates in a regenerative cycle with a single, remember, thermal power plant, that is Rankine cycle. Single open feed water heater as shown in figure. Okay. For the state point shown, the specific enthalpies are H1 is equal to this, and my dear, H2 is equal to this. Okay. They have given the H1 that is at point this one, and H2 at this point 2, right? I hope it's clear to you. Everybody, diagram is visible now? Please tell me, diagram is visible or not? Please tell me, bacha party. Okay. So here I go. Here I go. See, now my dear, you know that H1 and H2 is given, right? H1 is equal to what, my dear? 2800. Okay. H2 is given, that is 200. Both having unit what, my dear? Kilojoule per kg. Both having unit kilojoule per kg, right? Now, my dear, now you can check out Anish Kumar 3000. Okay, okay, very good. Anish, very good. Now, my dear, now you know that the formula for that balancing of, जो balance करते हैं हम लोग किसको? Feed water heater को. So what you will get, my dear? What you get? S3. See, my dear, S3. See, I'll explain. You know that here it is feed water heater, so definitely it is S3. So my dear, if I took the feed water heater like this, so you know that it is H1 is coming from this, and that is what, my dear? 20%. They are utilizing 20%. That means it is 0.2 H1, and from here H2 is coming. So definitely if it is 0.2, so definitely H2 will be what, my dear? 0.8, and it should be what, bacha? यहाँ पे क्या होगा? S3, and it is will be complete one. So I can say S3 is equal to 0.2 H1 plus 0.2 S2, sorry, 0.8 S2, right? Bacha party, of course it should be. So my dear, 0.2 H1, that is nothing but 2800 plus 0.8 S2, that is 200. So my dear, S3 will be कितना आएगा बच्चा? कितना आ जाएगा ये? That is 28 दूनी 56, 560, राइट ना? 560 हो जाएगा ये, It is 560 plus 8 dun 16. 560 plus 160, that is 720. Answer will be 720 kilojoule per kg. I hope everybody got it. Number 1 is correct. Number 1 is correct. Anish, yes. Anish Kumar, very good dear. It's 720. Very good. Anish, you are most welcome. Okay. Now I'll go for the next one. See. In a steam power plant operating on Rankine cycle, steam enters the turbine at 4 megapascal. कितने पे enter हो रहा है? 4 megapascal. Okay. And 350 degrees centigrade. And exits at pressure of 15 kilopascal. Then it enters the condenser. And exits as saturated water. Next pump, feedback the water to the boiler. Okay. The adiabatic efficiency of turbine is given, that is 90%. Okay. The thermodynamic state of water and steam are given in the table. Okay. And my dear, what they are asking, let me check. They are asking, is it visible? Let me check. Yes, it's visible. No issue on that. So H is the specific enthalpy, S is the specific entropy, V is the specific volume. Subscript F and G denote saturated liquid and saturated vapor. Okay. Now, my dear, you have to find out. What you have to find out? They said heat supplied to the cycle. It's Rankine cycle. So definitely, my dear, it will be look like this. It is Rankine cycle, na? So see. Right, it should be TS diagram I'm drawing. Okay, bacha party. TS diagram I'm going to draw. Okay, so here, listen to me very carefully. Listen to me very carefully, bacha party. Anish, listen to me, beta. Okay, so see here, my dear. Okay. It's going to be 1, it is going to be 2, it is going to be 3, it is going to be 4, right? Right now, bacha party, like this. And you know that, my dear, WP, that is pump work, will be what, my dear? S3 minus H4. And you pump work, you know that VF DP, right? It should be what, my dear? S3 minus H4. S3 is nothing but S3 minus H4. So from here, my dear, VF is given, that is none other than bacha party. Kitna? 15 kilopascal. It is what, my dear? 0.00104. So 0.00104, right? 001014, sorry. 1014. Pressure. That is what, my dear? 4000 minus 15 is equal to S3. S3 is what, bacha? S3 will be what? So S3, you can see, my dear, in the diagram. S3 is what? HF at 15 kilopascal. So it should be what? 15 kilopascal at 225.94. What, my dear? 225.94 minus H4. So from here, you'll get H4. And my dear, H4 will become how much? H4 kitna aa raha hai, bacha party? Your H4 will be 229.98. 229.98 kilojoule per kg. Okay. Now, my dear, if it is H4, we got it. Now, you know that Q supplied will be what? H1 minus H4 from bracket, that is H1 minus H4 in Rankine cycle. So H1 is nothing but superheated. So it is directly given, that is none other than 3092.5. So I will took that 229.98. My dear, I'm going to get an answer. And that answer will be what, my dear? 2863. Actually, the answer is 2862, right now? 0.6 something or 5 to something is there, right? It is kilojoule per kg. That is approximately, it is equal to 2863, right? Option number 3. Anish beta, had you got it? Guys, do hit like, share and subscribe the session if you have came first time. Okay. Yes, bacha party. So now we are going for the next. Anish, समझ आ रही है बात? ये सर के ऊपर गंगा बह रही है. Very good, Anish. Yes, got it. That's very good. Here I go for next. See, this kind of a simple question has been asked in the GATE examination. Can you believe this? Right? आपको लग रहा होगा कि यार ऐसा क्वेश्चन मेरे को आ जाए तो डेफिनेटली आई विल फोड़ दूंगा गेट को. ओके, नाउ दे आर आस्किंग द नेट वर्क आउटपुट. नाउ दे आर आस्किंग the net work output in the same diagram. So net work output will be what, bacha? See, I'll explain once again. Net work output is nothing but the work done produced by a turbine minus work done produced by a pump, right? So now, my dear, I'm going to proceed, but before that I want to let you know few things. Few things के बारे में बता दूं मैं. I'll tell you about the few things which are very useful to know, my dear. See, now wait. Now see, what should be the work done? Work done क्या होगा बच्चा? Work done will be what? Yes, it is nothing but S2 minus, right? Work done, very good, very good. See, where? Okay, here. Work done will be what, bacha? H1 minus H2, right? Hayana, Are Hayana. So it is what? H1 minus H2, right? And one more thing that I want to add, they had given what they had given, they have given the adiabatic efficiency of turbine, right? So that we have to consider, right, bacha party? Okay, so if you got it, and my dear, one more thing that you can notice, that is what about pump work? So my dear, this is going to be 0. Why? It is negligible. Why it is so, my dear? Why I'm doing this? Because you know that pump is going to deal with the liquid, and volume of liquid is quite too much less than the volume of vapor, because in a turbine we have vapor, that is steam, dry saturated steam, na, superheated. So definitely जो work output लगेगा, that is work input लगेगा pump को, that will be going to be a negligible as compared to the turbine. So that's why I have taken it negligible, that means 0. Okay, I hope you got it. Now my dear, I know the H1, sorry, what I have done, let me check. It should, I know H1, I don't know S2, right? S2 I don't know, so S2 I have to calculate, because I don't know S2 will be over here or here. ये कहाँ आएगी I don't know ना, यहाँ पे आएगी कहाँ आएगी I don't know, right now. So it may be over here also na, in the wet region, right? So my dear, I will not take the risk, I will calculate. So my dear, how we can calculate S2? S2 will be H1 plus X into HFG, that is Hg minus Hf, right? अरे हाँ या ना बच्चा पार्टी. And right now we don't know the dryness fraction. अभी हमें dryness fraction ही पता नहीं है, right? So we are going to calculate the dryness fraction first, and then my dear we'll continue, right? So my dear, see, अभी you know that S1 is equal to, wait, okay, Anish, listen to me very carefully. Yes, very good, Anish, that's very good. You know that S1 is equal to S2. So my dear, you know that S1 is how much, bacha? Kitna S1? S1 will be how much? S1 is equal to S2, that is nothing but 6.5821. 6.5821, right? Arey Hayana, very good. 6.5821, right? Here I go. Here it is given. ये given है. Superheated point. Okay. So now my dear, what I'll do, just check out. So my dear, I'll put the value S1 is equal to SF plus X SG minus SF, right? S1, you know that it is SF2 X2, you can say HG2, right now? SG2 minus SF2. So my dear, SF2, that is at 15 kilopascal, right now? You can see 0.7549. 0.7549 plus what, my dear? X2 SG2 8.0085. SF2 will be what? SF2, that is nothing but 0.7549, right? Now my dear, you know that it is 6.5821, right? Now my dear, from here you will get x2 and your x2 value will be, बच्चा पार्टी कितना होगा value? Anybody guess? It is none other than 0.8033. कितना आ रहा है बच्चा? 0.8033. Okay, Anish, you are asking something. Let me check what you have seen. S1, S2. Okay, no issue. Anish, I hope you are getting, my dear. Okay, you got x2 now. So my dear, S2 will be, it is what? HF1, huh? HF2. Okay, x2, HFG2, right? So HF2, we can check it out. So HF2 will be what, my dear? 225.94 plus 80.80, what, my dear? 33 Hg. Hg is what? Hg is nothing but 2599.1. 2599.1 minus HF. 225.94. So my dear, from here you'll get S2. And S2 आपका कितना जाएगा? S2 कितना आएगा बच्चा पार्टी? Your S2 will be nearby 2132.3. 2132.3 kilojoule per kg, right? I hope you got it, bacha. Okay, now my dear, see, you got H2 now. Now my dear, you know that W turbine, that is equal to W net is equal to, bacha party, I have already drawn H1 minus H2. So H1, you know that it is what? 3092.5, right? 3092.5. So I can write 3092.5 minus H2, and that is the value we have, 2132.3. 2132.3. So from here, but my dear, you know there is a adiabatic efficiency of turbine is given in the question, and that is what, my dear? Kitna diya given hai? It is given, na? Okay, sorry, this is not the question. 90%. So you have to multiply this efficiency, that is 0.9. So my dear, what will be the required answer? What will be the required answer, Anish? Anish beta, it is 864.18. It is 864.18 kilojoule per kg. Okay, I hope you got it, bacha party. This will be your required answer. This will be your required answer, bacha. Okay, kitna aaya? 864, but here they have given 860, 775, 957. So my dear, the answer will be 864. That is third one. Third one is going to be correct. Okay. Okay, bacha party, I hope you got it. Sir, since option in question is given far away, so can we took dryness fraction as 0.9 always without calculating it? No, you can't. You can't. I want to tell you that plus minus 5% error is allowed, my dear. Plus minus 5% of error is allowed. Remember, okay. 864.18. So your option will be what, my dear? आपका ऑप्शन क्या होगा? Your option will be number 3, that is 860, right? Plus minus 5%, plus minus 5%. So 860 का क्या होगा? Okay, I hope you got it. You got it now. So this will be your option will be going to, you have to choose the option, this one. ये लगाएंगे आप option. Wait, sorry. You can choose this one. Third one is going to be correct option, right? Okay. No, don't take the dryness fraction without calculation. You will trap, my dear. कहीं ना कहीं फंस जाओगे. And guys, those who have came first time in this channel, they can just do it, like, share and subscribe the session, so that they will get latest notification regarding any live class. Okay, bacha party, and I'll go for the next. Okay, in ideal Breton cycle operating between pressure limits of 1 bar and 6 bar has minimum and maximum temperature. Minimum and maximum temperature is given. The ratio of specific heat for the working fluid, that is gamma 1.4. The approximate final temperature at the end of compression and expansion process are respectively. What they said? They said that approximately final temperature in Kelvin at the end of compression, that is T2, and at the end of expansion process, that is T4, we have to determine. Okay, We have to calculate this. Yes, bacha party, how we can proceed? Yes, anybody? Anish, those who are watching, please tell me, bacha party, how you can proceed now? How you can proceed? Yes, bacha party, please tell me. Please tell me, bacha party. Come on, be fast. Haji, C, my dear, C. You know that Breton cycle is look like this. ऐसी कुछ होती है cycle. No, so one of my student asked yesterday, there's a question, sir, why this process is going to be long? Why this line is long in length as compared to this? My dear, this is going to be expansion. So expansion is going to be long, then and only the cycle is useful. Otherwise, it is not. Right now? One, two, see the clockwise direction. 3, 4, right? And 1, 2 is nothing but what, my dear? 1, 2 is nothing but isentropic compression. 3, 4 is nothing but isentropic expansion. And this 2, 3 is nothing but constant pressure heat addition. 3, 4 is what, my dear? Constant pressure heat rejection. You know that it is P is equal to C. It is also P equal to C. It is TV raised to power gamma is equal to C. And 1, 2 is also what? Adiabatic, right? My dear C. Can I say if it is adiabatic? So can I apply this? That is T2 by T1 is nothing but P2 by P1 raised to power gamma minus 1 upon gamma. Am I right? Am I right, bacha party? Guys, be fast. Okay. I hope you got it. Yes, bacha party. If you got it, then please let me know. My dear, see here. See, they have given limits of pressure 6 by 1, right? So I'll get 6 raised to power 0.4 divided by 1.4. So my dear, from here I'll get T2 and T1 is what, my dear? Minimum 300 multiplied by 6 raised to power 0.4 divided by 1.4. So your T2 will come around. T2 आपका आ जाएगा बच्चा पार्टी. It will be around 500 Kelvin. It is what, my dear? 500 Kelvin. Similarly, you can just apply for T4 now. So you can just write T4 by T3 again because it's isentropic reversible adiabatic. So you can apply the equation T4 by T3, that is nothing but P4 by P3 raised to power gamma minus 1 upon gamma. But I already told you P4 is equal to what? P1, right? And it is what, my dear? P3. P3 is nothing but P2, right now. So it is what? Gamma minus 1 upon gamma, right? 1.4. So my dear, can I say T4 is equal to T3 multiplied by what? 1 by 6 raised to power 0.4 divided by 1.4. And my dear, from here T3 is given, that is 1500. T3 कितना दिया बच्चा? 1500. So you get T4 and T4 will come around 900 Kelvin. Okay, Bachcha party, I hope you got it. I hope you got it. Yes. Anish, had you got it? Now we have the limits. My dear, you see, this is 500, right? 500 and 900. Option number 1 is going to be correct. Right? Bachcha party. Very good, Anish. Here I go. The values of enthalpy of steam at inlet and outlet of steam turbine in a Rankine cycle are this much. Okay. Then respectively, neglecting pump work, the specific steam consumption. You know that, my dear, specific steam consumption, specific steam consumption is what, my dear? We have already learned this formula, if you remember, my dear, in gas turbine. That is what? 3600 divided by W net kg per kilowatt hour, right now? So my dear, it is what? 3600. W net will be what? 1800, 2800 minus 1800, that is 1000. So it should be what, my dear? कितना हो जाएगा? 3.6. Right? Number 1. It's very simple. Anish, I hope you got it, bacha. Anish, okay. Anish, I hope you got it. Here I go for the next. Here I go for the next, my dear. See, another question. Can I go ahead? Anish, very good. Here I go. Steam enters an adiabatic turbine operating at steady state with an enthalpy 3251.0 kilojoule per kg and leaves the saturated mixture at 15 kilopascal with a quality dryness fraction that is 0.9. The enthalpies of the saturated liquid and vapor at 15 kilopascal Hi and Hg is given, okay, respectively. The mass flow rate of steam is 10 kg per second. Mass flow rate of steam is given, that is 10 kg per second. Kinetic and potential energy changes are negligible, okay. The power output of the turbine in megawatt is, the power output of the turbine in megawatt will be, yes Anish, how we can calculate? It's a very simple question. बहुत सिंपल क्वेश्चन है. इट्स वेरी सिंपल बच्चा, वेरी सिंपल. सी अगेन आई रिपीट, इट्स वेरी सिंपल. हाउ वी कैन कैलकुलेट माय डियर? सी अगेन आई टेल you. Rankine cycle I will draw the same cycle. There is no changes in the cycle, right now, my dear. We are going to draw the cycle. See, okay, it is 1 2 3 4, right? Very good. Now idea what they said neglect the power output from the turbine से find out करना है, from turbine only. So my dear, from turbine, because you know that it's a turbine na, so it is what WT. So W2 will be what bacha? It is H1 minus H2 multiplied by mass flow rate of steam, then and only we'll get in what megawatt, right? We got in kilowatt, right? So see my dear, how we can calculate bacha? Very good, mass rate. Very good Anish, very good dear. Yes, so it's going to be a very easy question, right? It should be what? 2800 minus 1800. No, it's not like that. Power, sorry. Okay, so what should be the answer, guys? Be fast. Now see, we don't know, we know about H1, right? H1 is going to be what, my dear? Hg, and it should be none other than क्या हो जाएगा? It is 3251 given in the question, right? Now my dear, I have to calculate H2, right? H2 calculate करना पड़ेगा हमें, okay? So my dear, see, so I know H1 is given, that is superheated state, that is 3251, right? Now my dear, S2, because I don't know S2 will be over here or at here, so it's better you calculate. So S2 is what? HF2 plus X2, and it is what? Hg2 minus HF2, right now. So my dear, see, I'll go for the next slide. So my dear, H2 is nothing but HF2. So HF2 will be बच्चा कितना है? HF2, that is 225.94, okay. So I'll took 225.94 plus what, my dear? 0.9, and Hg2 will be what? 2598.3 minus 225.94, right? So from here you will get S2. So your S2 will be बच्चा पार्टी कितना आ जाएगा S2? Your S2 will come around, my dear, come around 2361.06. 2361.06 kilojoule per kg, okay. Now my dear, you can calculate the work done, the power produced by the turbine. So it will be mass flow rate of steam multiplied by S difference, H1 minus H2, not H2 minus H1. So it is 10, H1 is given, that is 3251, right? It is 3251 minus 236. So it is what matter? कितना आएगा ये? It is what बच्चा पार्टी? It should be 8.89. कितना आ रहा है ये? 8.89 मेगावाट, राइट ना? ओके, एक्चुअल वैल्यू क्या आएगी? 88, राइट ना? 8899. एक्चुअली यहाँ पे वैल्यू क्या आएगी? 8899.3 किलोवाट. So multiply by 10 raised to power minus 3, that is in megawatt. So it will be this. Okay, so option will be बच्चा क्या हो जाएगा? Option this one. Okay, Anish, is it clear now? What about other people, those who are watching? It should be 8.89, right? 8.89 हो जाएगा. Okay, I hope you got it, बच्चा party. Yes, is it clear now? Okay, so here I go for the next one. See, in a simple Breton cycle, pressure ratio is 8. Okay, temperatures at the entrance of compressor and turbine, entrance of what, my dear? Compressor and turbine, that is T1 and T3 is given. Okay, both compressor and gas turbine have isentropic efficiency 0.8. Okay, the gas assumes a constant value of Cp, okay, equal to 1 kilojoule per kg Kelvin. Ratio of specific heat, that is gamma, 1.4. Neglect changes in kinetic energy and potential energy, and they are asking the thermal efficiency of the cycle in percentage. Thermal efficiency, they are asking thermal efficiency. So my dear, how we can calculate? It's very easy, it's very simple, right? Are हाँ या ना बच्चा पार्टी? Yes or no? Right? Okay, so here I calculate, my dear. चलें calculate करें. So here first let's draw the diagram and then we'll calculate each and everything. Okay बच्चा पार्टी? So here let's calculate. You know that TS diagram of Breton cycle, but here we have to show the isentropic efficiency as well. So my dear, I'll show the figure, don't worry. So here okay, it is 1, 2, 3, 4. Okay, okay, it is 2, it is 3, sorry, 4. Now the question is, you have to differentiate as well, right? Sorry, so I can dash mark कर दूं यहाँ पे. Okay, it is what, my dear? TS diagram. Okay, now my dear, can I say like this? Can I write like this? That is T2 by T1 is equal to P2 by P1 raised to power gamma minus 1 upon gamma. So my dear, from here I'll get T2 because T1 you know that. So T1 is what, bacha? It is given in the question. T1 300. So my dear, you can do 300 into P2 by P1. So my dear, it is the pressure ratio 8. Okay, pressure ratio is 8 raised to power 0.4 divided by 1.4. So my dear, you are going to get T2 and T2 will come around, bacha party. How much? T2 will come around. T2 कितना आ जाएगा? It will be come around 543.43. 543.43, right? 543.34 Kelvin, right? It is T2. Now, my dear, isentropic efficiency of compressor will be what? It should be none other than the ideal rise in enthalpy, that is T2, my ideal rise, that is S2 upon H1 divided by the actual rise, that is nothing but S2 dash upon H1. But my dear, I can put the values of enthalpy in terms of Cp into T, Cp into T, right? So Cp will get common and that will get cancelled out and we are left with the only temperature. So it will be like this only. Sorry. अरे हाँ या ना, आइडियली क्या लगेगा, कम लगेगा. ओके बच्चा पार्टी, yes or no? So you know that it's 0.8. T2 you know that 543.34. T1 you know that 300. T2 dash we have to find out. T1 you know that 300. So my dear, from here you'll get T2 dash, and your T2 dash will come around बच्चा पार्टी how much? T2 dash आपका आ जाएगा 604.3. 604.3 Kelvin, right? I hope everybody is getting. Bacha party, please listen to me very carefully. Okay, okay, very good, very good. Here I go. So it is T2 dash, right? Now my dear, similarly, I can go for that is T3 by T4. T3 by T4 I can find it out, right? So my dear, see, similarly, I can write T3 by T4 is equal to P3 by P4 raised to power gamma minus 1 upon gamma. So it is 8 raised to power 0.4 divided by 1.4, right? Let me write at the top side 0.4 divided by 1.4, and it is what, my dear? It is T3 by T4. You know that we have to find out T4, and T3 is given. T3 is what, bacha? T3 is how much? T3 is what? 1400 Kelvin, right? T3 is 1400 Kelvin. So my dear, I'll get T4, and T4 will come around. T4 will come around 772.86. Okay, everybody. Anish, I hope you're getting bacha party. Okay, now I'll go ahead. आगे चलते हैं अभी थोड़ा सा. Okay, so my dear, you got T4 now. So again, you can apply the funda for isentropic efficiency of turbine, and that will be bacha party what? That will be actual drop in enthalpy, that is S3 minus H4 has divided by the ideal enthalpy drop, because ideally you are going to get lot more work as compared to the actual condition, right? So my dear, I can write T3 minus T4 dash divided by T3 minus T4. So it is 0.8. T3 is going to be what, bacha? T3 is given, that is 1400, I think, right? Let me check again. 1400, right? My dear, T4 dash we have to find out. T3 you know that 1400, and my dear T4 you know that T4 is how much, bacha? 772.86. So my dear, from here you'll get T4 dash. So your T4 dash will be bacha how much? Yes guys, be fast. It is none other than 898.3. It is 898.3. 898.3 Kelvin. I hope you got it. Now my dear, I have to calculate. What I have to calculate? See here, I have to calculate. They said I have to calculate thermal efficiency. For that I need work output, right? So I can calculate, my dear, net work. So net work will be what, my dear? क्या होगा बच्चा पार्टी? Guys, be fast. क्या होगा? It should be T3 minus T4 dash minus CP into T2 minus T1, right? So here, sorry, T2 dash minus T1. I'm very sorry. So see in the diagram, my dear. The W net will be CP into T3 minus T4 dash, right? Minus CP into what, bacha? It should be T2 dash minus T1. Am I right? So again, I'll do same thing. So here, see, my dear, it should be CP bracket T3 minus T4 dash minus CP into what, my dear? T2 dash minus T1. So I'll get the value here over here, that is 1. T3 is, you know that T3 is 1400. T4 dash we got 898. 898.3 minus CP, that is 1, bracket T2 dash. T2 dash what we get? T2 dash we have 604.3, right? Minus T1, that is 300. So my dear, from here you will get the answer, and answer will come around, bacha party. It will come around 197.4 kilowatt. It is what, my dear? 197.4 kilowatt. So this is going to be your net work output. But my dear, I have to calculate input, that is heat supplied. So it should be what? It should be MCP. MCP what? T2 dash minus T3, right? See, you have supplied the heat from this, not from here. So it should be what? T3 minus T2 dash. Okay. So CP T3 minus T2 dash, right? So it is 1 bracket T3 1400 Kelvin, T2 dash, we know that. T2 dash, we got it, that is how much? 604.3. So it will come around, bacha party. How much? Nearby 800. Nearby 800, yes or no? That is 795.7. 795.7. Okay, kilowatt. Wait. Now, my dear, eta, that is will be what? Output, that is 197.4 divided by 795.7. So it will come 24.80%. My dear, this is going to be no lengthy tha, but it is quite very easy question. You can get full marks for that, right? The 24.8 will be the correct option. Here I go for the next one. The power required by the compressor in kilowatt per kg of gas flow rate is what, my dear? That we have to calculate. Bacha party, be fast. Gas flow rate, what it should be? हाँ बच्चा, क्या होगा ये? It is going to be how much? T2 you have calculated, T2 dash you have calculated. So definitely it should be what, my dear? कितना है? हाँ जी बच्चा, it should be what? What they said? They said compressor, na? So here we have compressor. This is our compressor, that is T2 dash minus T1. So I can just check it out. So WC, that is what, my dear? CP into T2 dash minus T1. So you know that CP1, it is 604.3, T1 3. So it will be what, my dear? 304.3. That is, this one is the correct option. Okay. So option number 3 is going to be correct. Okay, bacha party. I hope everybody got it. So here I go for the next. Steam with specific enthalpy 3214 kilojoule per kg enters an adiabatic turbine operating at steady state with flow rate 10 kg per second. As it expands at a point where H is 2920 kilojoule per kg, 1.5 kg per second is extracted. Okay, mass of steam. For heating purpose, that is bleeding. The remaining is 8.5 kg per second. Further expands to the turbine exit where H is going to be 2374 kilojoule per kg, neglecting changes in kinetic and potential energies. The net power output. Steam with specific enthalpy 3214 kilojoule per kg enters adiabatic turbine operating at a steady state with flow rate 10 kg per second. As it expands at a point where H is equal to 2920 kilojoule per kg and mass flow rate 1.5 kg per second is extracted for heating purpose. The remaining 8.5 kg per second further expand to the turbine exit where H is equal to this much, neglecting changes in kinetic energy potential. The net work output they are asking. My dear, we have done already this kind of question, right? So you can solve it very easily. बहुत आसानी से आप कर लोगे. Am I right now? Bacha party, yes or no? Yes or no, bacha party? Can you tell me? हाँ जी बच्चा. Yes, guys, be fast. You know that. पहले तो see. Suppose to be this is your turbine, right now, or you can just write like this, my dear. See. ये टर्बाइन नंबर 1 होगी, okay, and you have feed some Wait, and this is your turbine number 2. This is your turbine number 2, right? My dear C. Okay. One. This is 2. And it is going to be rejected. That is 3. Right now, ऐसे ही कुछ हो रहा है. Am I right? Yes or no? So, my dear, this is your turbine number 1. This is your turbine number 2. Now, my dear, you can calculate the whole mass. Here, that is M1 is there. Here, we have M2 is there, right? So, W net, WT, the total will be, total क्या हो जाएगा बच्चा? Total will be what? M1, right now? अरे हाँ या ना? Very good. See, my dear, it should be M1 into what? H1 minus H2 plus M2. It should be what? S2 minus S3. Am I right? M1 is given. M1 is given, that is 10. M2 is given, that is M3 is given 8.5. Right now? अरे बच्चा आपने M2 तो हीटिंग पर्पस के लिए निकाल लिया, राइट ना? इसमें से कुछ चला भी गया है ना? There is something we have taken for heating purpose, and that is what? 1.5. So definitely this mass will be over here, that is 8.5 now. And here we have what, my dear? 10, right? And 1.5 that you have taken for heating purpose, right now. So M1 is, that is 10. H1 is given. H1 is what, बच्चा? H1 कितना दिया है बच्चा? वाडी बी फास्ट यार. 3214 कितना दिया है? 3214. अरे ये दिया है यार 3214 and up to 2920. Okay, plus M2, that is 8.5, because 1.5 you have taken for the heating purpose. Very good. And the enthalpy will be 2920 minus 2374. Right now, please try to understand this thing we have already studied. Right now, very good. My dear, what you are going to get? W net, and your W net will come around bacha party. Kitna aa raha hai? It will come around 7581 kilowatt. And this will be your correct answer. Okay, this will be your correct answer. I hope you got it, bacha party. This is going to be your correct answer. Okay, so my dear, now we'll go for the next. आगे बढ़ते हैं अभी. Next question. See, an ideal reheat Rankine cycle operated between the pressure limits 10 and 8 megapascal. Reheat being done at 4 megapascal. Okay, the temperature of the steam at the inlet of both turbines, temperature of the steam at inlet of both the turbines, that is what, my dear? 500 degrees centigrade. And enthalpy of steam is 3185 kilojoule per kg at the exit of high pressure turbine, and 2247 kilojoule per kg at the exit of low pressure turbine. Okay, the enthalpy of the water at the exit of the pump is 191 kilojoule per kg. Use the following table relevant data disregarding the pump work, the cycle efficiency. They are asking for calculating cycle efficiency, bacha party. We have to calculate the cycle efficiency. So how we can calculate, my dear? कैसे calculate करेंगे? It's a case of reheating, right? It's a case of reheating, bacha party. You know that? अरे हाँ या ना? Very good. Right. So my dear, we are going to calculate each and everything right now, but they have said the temperatures are equal, right? Right now, so here, see, my dear. Again, I'll draw the diagram, my dear. See, I'll go to the next slide. See, it's a case of reheating. So let me draw the diagram. right? Yes. Okay, bacha party. Now listen to. Okay. It is like this. Right now? Diagram कुछ ऐसा ही है. Am I right, bacha party? Yes or no? Of course, it should be like this. So see, 1, 2, it is 3, 4, 5, and point number 6 may be in the wet region. It may not be at saturated vapor, right? It may be at upper side. Okay, I hope you got it, bacha party. Now see, they said we had to calculate the thermal efficiency. They said we had to calculate thermal efficiency, right? So guys, if you want to calculate thermal efficiency, so I can easily calculate, right? I can easily calculate. And how I can calculate? I have a diagram, right? So my dear, I'm going to calculate the work done and I'm going to calculate the heat supplied, right? You know that. Yes, bacha party. So my dear, see here. My work done will be, first of all, my work done will be, that is first S3 minus H4 plus what, my dear? H5 minus H6. Is it clear? Right now? So my dear, I can calculate the work done first, right? So my dear, you know that it is 3399, it is given. I'll tell you, see the question. They said 500 and 500, right now. So you can check it out, my dear. They said 10 and 8 megapascal with the reheat being done at 4 megapascal. Okay. The temperature of the steam at inlet of both the turbine, that is 500. Okay. Enthalpy of the steam and the enthalpy of steam is 3185 at the exit of a high pressure turbine. That means they have given, it is what? It is nothing but H4, my dear. It is क्या? ये क्या है हमारी? H4 है. It is our H4. S3, you can check it out. S3 is nothing but what, my dear? 8 megapascal. That is 3399, right? So I can put the value. So my dear, it should be 3399 minus 3185, right? Plus H5. H5 क्या होगा बच्चा? 3446. क्या होगा? 3446, right? See here. Up H4, no, sorry, H5 will be like this only. See, H5 will be at 4 megapascal, so it should be what, my dear? 3446, right? And at the end of low pressure turbine, the enthalpy is 2247. It is mentioned in the question, the same thing that I have taken. So my dear, you will get W net from here, and your W net will become, bacha party, how much your W net will be? Your W net will be how much? It will come around 1413 kilojoule per kg. We got WT. Now, my dear, heat supplied will be what? You have supplied the heat. It is nothing but what, my dear? S3 minus S2 plus what, my dear? H5 minus H4. Right? So again, you can S3, you know that. S3, you know that. We have already taken S3. That is 33399. S2. Guys, how we can find out S2? Now, the twist comes. So S2, right? Haji bacha party. What it should be? क्या होगी S2? And that is given now. Given है, and that is 3446. That means this one now. S3. Sorry. 3399 that I have taken S2. S2 means this one, na? So I can take this. I can take this what? I can take this as 3185, right now? अरे हाँ या ना बच्चा पार्टी, had you got it? बात समझ आ रही? It is one. See, sorry. It is given, I think. It is given. Let me check. Yes, the enthalpy of the water at the exit of pump is given 191. Sorry, it is given 191. Sorry, 191 plus now H5 minus H4. So this is your H5 and this is your H4, right? So my dear, H5, you know that H5 is already given, that is 3446. Now, how we can took my dear, that is H4. H4 कैसे calculate करेंगे, right? That is, yes. बच्चा पार्टी, how we can calculate H4? That is 3185. कितना है ये? H4 3185 given. So my dear, you'll get QS and your QS will come around बच्चा पार्टी कितना? 3469. Okay, so now my dear, you have enthalpy and that will be 1413 divided by 3469 and you will get around कितना आएगा बच्चा पार्टी ये? 40.7. It is 40.7%. So this is your numerical. Okay, I hope you got it. I hope you bacha party you got this. That is, it is quite lengthy, kind of this numerical, the numerical based on the steam thermal power plant which they are asking in gate examination, and this is for 2 marks. So that is quite lengthy, but it is quite very easy to understand. Okay, बहुत आसान होता है उसको निकालना. Now see my dear, the next question. In a power plant, water density given is pumped from 80 kilopascal to 3 megapascal. The pump has an isentropic efficiency 0.85. Assuming that the temperature of the water remains the same, the specific work supplied to the pump is. Now they are asking, that is how much work you have supplied to the pump, that we have to identify, right? Bacha party, how we can identify? Yes, bacha party. Guys, be fast. Right now. So how we can my dear? It is what? VFDP. अरे right now क्या होगा बच्चा? It is VFDP, right now. Very good. But they have given the efficiency, right? So actual work will be, my dear, you know that VFDP is there right now. W required for pump. So my dear, VF is given, that is how much? VF is given, but they have given density. So it should be none other than what, my dear? VF uska reciprocal, that is 10 raised to power minus 3. It is 3 megapascal, that is 3000 kilopascal minus 80 kilopascal divided by what? Because it is efficiency is there, na? Efficiency is given 0.85. So I can divide it 0.85 and I'll get answer directly. It's very easy question, my dear. 3.43 kilojoule per kg. So this option is going to be correct. Okay, bacha party, I hope you got it. Very good. I hope everybody got it. Here I go for the next. Steam at velocity 10 meter per second enters the impulse turbine stage with a symmetrical blading. Okay, having blade angle that is 30 degree. The enthalpy drop in the stage is 100 kilojoule. The nozzle angle is 20. The maximum blade efficiency. And my dear, you know that maximum blade efficiency for turbine. Okay. So guys, now I'll see, my dear. Now I'll go for the eta max. That you know that eta max is how much, bacha? Eta max क्या होता है? Eta max is what, my dear? Eta max क्या होता है? Cos square alpha, right? And they have given alpha, nozzle angle. Alpha is what? Nozzle angle. So my dear, it is cos square of 30 degree, right? And you will get the answer. And the answer is what, my dear? Cos square alpha की value निकालेंगे. So it is 0.88. It is what, bacha? It will come around 0.8830. That is what, my dear? 88.30%. Right now, it is eta max. Okay, it's eta max. Okay, bacha party. Here I go for the next one. So they said calculate eta max. So here we have calculated. Remember, my dear, that eta max is what, my dear? 88.30. Okay. Okay, bacha party. Here I go for next. Here I'll go for the next. An ideal Breton cycle, atmospheric air, ratio of specific heat, that is gamma 1.4. Okay. At constant pressure is given. At 1 bar and 300 Kelvin is compressed to 8 bar. The maximum temperature in the cycle is limited to 1280 Kelvin. If heat is supplied at the rate of 80 megawatt, that is, they have already mentioned the heat, that is QS, 80 megawatt, the mass flow rate of air required in cycle. They are asking what, my dear? Mass flow rate of air. Remember, they are asking mass flow rate of air, bacha party. Okay. So now we have to calculate the mass flow rate air. So how we can calculate the mass flow rate of air? Yes. Anybody have any idea about it? That bacha party, please tell me. How we can calculate? It's very easy, my dear. It's very easy. Simply you can just find out. You can just find out what? T2, right? You know that Breton cycle is like this. I have already drawn it many times in this session, right? आज के सेशन में बहुत ज्यादा कराया है. Okay. One, two, three, four. One, two, three, four. That is TS diagram now. Right. So, my dear, they are asking, that is what, if the heat is supplied at the rate of 80 megawatt, the mass flow rate. They are asking for the mass flow rate. So, my dear, if I calculate T2, because I don't know the T2, right? If I calculate T2, then it is quite easy for me to calculate, right? So, my dear, see. You know that it is isentropic process, so I can say T2 by T1 is nothing but what, bacha? P2 by P1 raised to power gamma minus 1 upon gamma, right? So, my dear, P2 is what? You can check it out. 1 bar and 8 bar. That is what, my dear? 8 raised to power 0.4 divided by 1.4, right? So, my dear, from here I'll get T2. T1 is given. T1 is 300. It is what, my dear? 300. So, you'll get T2. And T2 will come around 543 something. 543 something. T2 is what? 543.43, right? Because I have already calculated this in the last numerical as well, right? We got T2. Now, my dear, QS is nothing but what? 223 is nothing but a constant pressure heat addition process. This, here we are adding heat, and from here the heat has been rejected, right now. And here, what, my dear? Work of turbine, and here the work of pump has been supplied, right now. So, my dear, QS will be what, my dear? MCP, T3 minus T2. So, mass flow rate, that will be what, my dear? CP. CP is given. That is how much? 1.005. T3, we know that. T3 is also mentioned. 1280. T2, we have calculated 543. Right? Divided by QS. QS is 80. 80 into 10 raised to power 3. So, my dear, I will get mass flow rate. And your mass flow rate come around, bacha party, kitna aega? 108. 108 into, right now, 108.07. 108.07 kg per second, right? Okay. So, this will be the correct option, right, bacha? Sorry, I have done. इसको मैंने उल्टा कर दिया. That is, it should be 1 by m. If I done like this, then it should be 1 by m, right? ये 1 by m होगा. 1 by m is equal to this. Then, my dear, m will come around this. Okay. So, I hope you got it. Okay, bacha party. I hope you got it. Okay. So, this will be the correct option for this one. Okay, bacha party. Okay, my dear. So, guys, here we have finished. I think 15 question. 15 क्वेश्चन हमारे हो चुके हैं. Okay. So guys, we'll see you in the next class. Okay, and I want to tell you, those who are new, then I want to tell you, my dear, we have a daily class. We have a daily class for the GATE PYQ, GATE previous year question at, my dear, 3 p.m. regular. 3 p.m. regular. Okay, 3 बजे होता है दोपहर में. So बिल्कुल जो है लाइव आना नहीं भूलें and get benefit of this free of cost session, my dear. Okay, and one more thing that I want to add, my dear, कि please revise each and every subject so that you will have some kind of knowledge, then and only you are able to attempt the question, otherwise it will not. That means what I mean to say, when you come to the session, before that you just go through the formulas so that it is quite very easy to get the question and you can solve also, right? Then and only this session is going to be beneficial for you guys. Okay, so guys, take care. Bye bye. Shabba khair. One more thing that I want to add, please stay at home, stay safe, stay online with the Testbook.com. And जाने से पहले, my dear, if you are new to this channel, then subscribe the channel. Okay, and you can mark your attendance by hitting on the like button. So Jai Hind, Jai Maa Bharati.